Hello and welcome to this my first bash at a Flight Sim 2020 tutorial video. The plan today is we'll have an end-to-end look at installing the 320NX to hopefully using it with a degree of expertise. So we'll look at installing the aircraft from the FlyByWire website using their installer. We'll have a look at SimBrief. We'll also look at importing that data into the MCDU. Have a chat about VATSIM, the virtual air traffic simulation environment, although we won't necessarily use their services today. Then we'll fly a trip and look at SIDs and stars, descent profiles and ILS, and hopefully we'll take you from being a novice user to certainly an intermediate user of Flight Sim 2020. My background is all air traffic control. I've been out of the trade for a few years, but my information and knowledge should hopefully be fairly up to date. I have a background in both military and civilian, so yeah, hopefully a few useful bits of information along the way. Okay, let's get on with it. Okay, so the first thing we'll have a look at is installing the FlyByWire A32NX. Simply just type into Google A320X, A32NX download, and go to your fly-by-wire simulations. That'll get you to this page. Simply hit installer, download the custom built installer, and okay, I'm not going to do that because I've already done it, and then that will bring you to this page, or the installer, which will look like this. Okay, and this is where you can choose which aircraft you want to install. So you must do this first of all without Flight Simulator running, and this is updated quite regularly. And what we can see here is there are two sort of providers now. There's fly-by-wire simulations and salty simulations. So the one we're looking at is fly-by-wire, the A32NX. Now the version I'm using is the development version, but probably best to use the stable version. That's probably the most commonly downloaded. And simply click on that and follow the sequence through. And once that is complete, that will have automatically installed the 320NX into your Flight Sim 2020 community folder, and you should be ready to go. So simply run Flight Sim 2020, and then when you go in to select your aircraft, it will be in there, which we'll have a look at shortly. Okay, so we're going to have a look at SimBrief now, which is a flight planning tool, free to use, or a free subscription is available. There is a paid one as well. I'll explain the difference in a minute. So what's it for? Well, essentially in the real world, and indeed on Flight Sim when using the 320NX, you have to develop and produce a flight plan. And that is something that is essentially detailing how you get from A to B, not just the route you fly, but all the fuel aspects and weather and various other things. The operational flight plan that SimBrief will produce for you is very extensive. Whether it compares to what there is in the real world, I don't know. It's certainly the air traffic element of it looks identical to what I was familiar with. But it's a good tool, and you need this to fly the 320NX. So in the usual way, you'll need to create an account. So I'm already logged in. That's not my real name. That's the one I use for Flight Sim Matters. But if that wasn't there, you'd have the opportunity to log in, and you go to this screen. As you might expect, fairly standard, and just follow through the create an account. You do that via the Navigraph website, and once you've got your username and password, and you will also have a pilot ID if memory serves correctly, then you'll need to go back to SimBrief if it doesn't do it automatically and log in there. And once you've done that, you'll be met with this page. Initially it looks maybe a little bit daunting, but in reality you won't use too much of this, or you certainly don't need to. So the key thing we go to here when we're looking to file or create a flight plan is into the dispatch system. This is where we get into the meat of the flight plan, really. So here you need to, in the airline box, you need to type in the trigraph of the airline concerned. So, for example, British Airways will be Bravo Alpha Whiskey, Virgin Victor India Romeo, and there will be many more. I don't have the list to hand, but it's not easy to, not difficult to find. Flight number is a number of your choice, so let's just put 797 in there for argument's sake. Airport of departure. Now you need your ICAO code for that, and that's all this information can be found in the Flight Sim flight editor. But we're going to go from Gatwick today, which is Echo Golf Kilo Kilo. And we are going to go to Edinburgh, which is Echo Golf Papa Hotel. Now, just above the departure and arrival airport boxes, you've got the little cloud here, which will give you an instant readout of the weather. And the top line there will be the METAR, and the bottom is the TAF. I did say we were going to decode that, didn't I? So we can have a look at that in a second. And the alternate here, so your diversion, if for whatever reason Edinburgh becomes unavailable, that is Manchester, Echo Golf Charlie Charlie. And again, it will give you the weather there. The date today, the departure time is automatically filled in, and SimBrief generally assumes it's going to take you half an hour to get from where you are now to actually calling up air traffic and asking for your clearance, which once you become au fait with it is around about right. Then we go into aircraft type, and for the A32NX, the Neo, this is what you select here, A20N. Okay, and now into advanced aircraft options, your climb profile. So again, this is pre-filled for you. What does it all mean? Okay, so the numbers here, 250, 300, 78, that is 250 knots, 300 knots, and then 0.78 Mach, and that is determining your speed profile for climb. And so it's typically 250 knots below 10,000 feet, 300 knots or the Mach equivalent above, and 0.78 for the cruise is my understanding, but 300 and 0.78 is pretty close once you're above 10,000 feet from what I've seen. Cruise profile is the cost index, which is done automatically. You can play around with that if you so wish. And descent profile is a reversal of the climb profile. So you've got 0.78 Mach, 300 knots above 10,000, and then below 10,000 feet, 250 knots, which is standard worldwide, is my understanding, certainly within controlled airspace. Okay, the registration number for the aircraft is pre-filled in, as is all this, and the Speedbird 797 call sign is taken from what you've already filled in. Just going to the right-hand side here, I'm not going to lie, I don't know too much about what all of this means, but generally speaking, this is determining how detailed the flight plan that SimBrief generates will be. And when we have a look through it, and we're not going to look through it in too much detail, just in the interest of time, but some of these items you will potentially never use, some of them you will, and you can modify what you want, and then you can save your default selections. But generally speaking, in here I would certainly make sure that that is set to kilograms for units. So coming down here into your optional entries, as it says, they're automatically entered, but you can change them. So scheduled flight time, again pre-filled in. Departure runway, it has calculated that by looking at existing weather. Similarly, arrival runway, taxi out time, so it's factoring in 20 minutes for taxi out and 8 minutes for taxi in. And because of that, it will calculate the fuel that you require for taxi out and taxi in, as well as adding extra fuel for diversion, all that sort of thing, which we'll have a look at in a second when the plan is generated. But it's giving you the option here to load extra fuel if you so wish. Altitude, I generally do put something in there, so I'm going to put in flight level 360 today, and all the experienced air traffickers will probably tell me I've got the wrong semicircular in there. I can't remember off the top of my head which way around it goes. But we'll put 360 in there for the time being. Passengers, so you can determine how many you want in there. So let's go for mid-range and let's have 58, that's fine. Zero fuel weights, will be determined automatically. Dispatcher name, don't worry about that. Captain name is pre-filled. Pilot ID, this is the number that I've said you'll get as part of your registration, and you need to take note of that because you will need to enter that number into the MCDU on board the 320 NX so that it can import your information from SimBrief into the MCDU. That's how it makes the link. Okay, coming down here then, we're looking at the AIRAC cycle information. Now, what is the AIRAC cycle? Essentially, it's navigational data. Now, the AIRAC cycle is 4 weekly, and so you will get an update to this information every 4 weeks. This is real-world stuff. Now, in the free subscription, you do not get the most up-to-date AIRAC cycle. What's the risk of that? Well, potentially some of your flight plan information will be incorrect. So if you're going to use VATSIM, there may be mismatches with route data. But essentially, so this account, I've got 2 accounts, but this one in the Ollie Portman name here is the free account, which is this is the latest you're going to get on the free account, which is 2103, which means 2021 and the 3rd cycle, so around about February, March 2021. If you get the paid subscription, it'll be the most up to date. Okay, the flight planned route is next, again automatically calculated. So this is giving you the Lambourne 6 Mike SID, and then your Airways routes, and then this 6-digit code here is your star into Edinburgh, which we'll look at a little bit more in a minute. Now, if you want to have a look at alternative routes, then you've got the option to do that here. Just going to try and bring that down, and we can see what we're talking about. So as you click on the individual routes, you can see how they reflect in here. And this is I've deliberately picked this route because I know it works, but this will take a little bit of trial and error getting your route correct, because you can get some weird and wonderful routes that come up sometimes. And I have to say, without being biased towards the paid subscription, which I now have, I do find it's a little bit better with the paid option. But anyway, so let's go back to that top option there. You can see in here, by the way, is whether it's valid for the existing AIRAC and potentially where the route has come from. You have standard route documents, and I would have thought that this NATS one here, NATS is National Air Traffic Services, the main UK air traffic provider. If that's come from the SRD, which you can see in the bottom right hand side of their box, that is the approved current route that NATS would suggest for flying Gatwick to Edinburgh. So we'll stick with that. Okay, so let's close that down. Route Finder, historical weather, alternative airports, ETOPS. ETOPS is all to do with flying twin-engine aircraft over the Atlantic, which we're not doing today. And that's pretty much it. So once you've got, pretty much once you've decided upon your route, then you are done. And then we have to go to this button here and generate flight. So we'll go for that. Yes, we do. And then you will have your flight plan, and this is what it will look like. When you come to using VATSIM, there will be a need to file a flight plan with VATSIM, and simply you would need to take this portion, and that's the route that you need to file with VATSIM, but that's probably for another day, really. So this will be, this is what your flight plan looks like, although this is the real detail. And there is an awful lot of information in here which we don't need to go through, but SimBrief does offer its own tutorials on this. But one of the key pieces of information that we need to use in here, or need to establish in here, is block fuel, and that's a figure that you need to write down. So in this case, it is 4951 kilos. Okay, that really is SimBrief done. That information is now stored and will be ready for upload into the MCDU. So we shall have a look at that next. Okay, so I said I was going to give you a quick breakdown of METAR and TAF. METAR is Meteorological Actual Report, TAF Terminal Area Forecast. So what's about, or what's going to happen a little bit later on effectively. The METAR is what's going on now. So this METAR here is timed at 0850 UTC. UTC is the same as Zulu, so the time standard that we use in the aviation world. So the latest one we can see here is taken on the 10th of May at 0850 Zulu. And you can see here they're done at Gatwick every half an hour. So the previous one was 0820, 0750, etc. But the latest 0850. And so moving along, this is the wind, 220 at 9 knots. This is visibility, all the nines, which means greater than 10 kilometers. If it's less than 10 kilometers, it will tell you what it is there. And then this is the cloud cover, so broken at 1,300 feet in this case. If we go down here, in previous ones we can see scattered at 1,300, and then it was few. So the order it goes in is, in terms of coverage, sky coverage is few, then it's scattered, and then it's broken, so each of those being a greater degree of coverage than before. And then after that you've got overcast, which of course is full coverage. And then you've got some temperatures here, outside air +1.5 and the dew point +1.1, and then the QNH in use. Here you've got something different, so that's rain, and the minus figure, sorry, the minus symbol means light rain. And here you've got a little bit of additional information for the wind. It's basically that's saying it's variable between 170 and 250 degrees. Then into terminal area forecast. So slightly more complex, but essentially this is saying it was taken at 0455 Zulu on the 10th of May. 0455 Zulu, and this is then the validity. So it is valid from the 10th of May 0600 to the 11th of May at 1200. And essentially it's saying throughout that period generally the wind will be 230 at 10 knots, visibility will be in excess of 10,000 meters, 10k, and the cloud will be scattered at 2,500. However, it'll be temporarily on the 10th between 0600 and on the 10th between 1200 down to 8,000 meters in light rain, with the cloud being broken at 1,200. And then there's a probability, 30%. Probability, I've never seen any difference to 30% if I'm being brutally honest, is that temporarily between 8 o'clock on the 10th and 11 o'clock on the 10th, visibility will come down to 4,000 feet in rain and drizzle, with TAF and METAR potentially, I would imagine, other videos available on weather and decodes, but that's a basic overview. Okay, right, so let's get started here then. So when we're using the A32NX, we do things slightly differently with the setup of the flight. And that essentially means all we do in here is select the departure airport and the parking gate. Certainly if you're using VATSIM, you must start from a parking gate. And if we're going to run through the checklist on the aircraft from its cold and dark configuration, as it's often referred to, i.e. not started, then a gate is the most realistic and sensible place, as opposed to being sat on the runway threshold. So let's just find Gatwick and a suitable space. Strangely enough, we're already here. Right, so I tend to go over here, which is the, let's have a look, the South Terminal. There's never too much point in being too far away from the runway threshold. as we're using 2.6 today. So let's go there and set that as departure. And for, as I say, for when we're using the A32NX, that is all you do. You don't set your destination, you don't derive a route, because we've already done that in SimBrief. So that is the extent of what you do. So let's hit the fly button. Okay, let's jump into the cockpit then. So the first thing we'll do is configure the FlyPad so that it links up to your SimBrief account. So you go into settings down here. Well, I won't go into all of the settings in detail. We'll have a quick look at some of them. Need to make sure you're in kilos, but again, these are the default settings, so it should be the same. Hectopascals there for default barometer units. Everything else here is standard. Realism is up to you. I've got mine set to fast for the sake of the video today. ADIRS ordinarily would take around about 7, 8, 9 minutes to configure. So maybe worth having those to fast normally, but that's up to you. And then this is the page where we insert your pilot ID. This is a number that you will have been given during your SimBrief registration. Enter that, and that should link the two accounts. Then into your audio settings, again, personal preference and brightness, etc. there. Okay, so that should have linked both the FlyPad and the MCDU to SimBrief. I have hunted around in the MCDU for where to enter your SimBrief pilot ID, because that's certainly where it used to go, but I cannot find it anywhere. So I'm hoping that it is just simply inserting that number into the FlyPad that will work nowadays. As I say, this is the development version, not the stable, so it may well have changed. It certainly looks like it has. So let's, I'm going to refer now, in fact, to a checklist that I've developed, which has come from the checklist you get from within Flight Sim and also elsewhere that you may find more detailed lists. So it's not official by any means, but it works for me. I believe it's logical, and I think it covers all bases. So let's have a look at that and get going. So we'd normally this is the view we'd normally get the minute we hit the fly now, and as I say, we would turn on the FlyPad, and the other thing I do is turn off the air traffic comms if you're using the inbuilt air traffic, not VATSIM. I then conduct some sort of pre-power checks, if you like, and I make sure the parking brake is on. I make sure the engine switch here is in norm, which is the 12 o'clock position. Make sure that both engine master switches are selected at off, throttle in idle or 0 there. That is probably the one that is most commonly out of position for whatever reason. Flaps up, speed brakes, spoilers retracted, and also need to make sure that the windscreen wipers are off, which are here and here. And then we can concentrate solely on this panel and get some power going. So we hit battery 1 and 2, and then we select external power, which is usually available. If it's not, the batteries will give you limited power supply, but you'll need to rely on your APU, which we'll select now. We will start up the APU in any case, because that is what essentially feeds the power to the engines to start them when we get round to that in a little while. So whilst also on this panel, I get the lights on. Again, I'm not sure if that's how it's reflected in the real world, but it's certainly convenient and how I do it while I'm up here. We're not ready for taxi, so I don't change any of that just yet. You might have just heard some cabin crew commentary, which is a feature of the development version. So yeah, seatbelts there, no smoking, emergency exits, lighting, you arm that, and I will adjust the overhead lighting. And if you were literally in a cold and dark situation, this button here would be quite useful to provide lighting to the whole cockpit. But that's that. In fact, one thing I've forgotten, I would normally do this immediately after selecting power, is turning on the ADIRS. It's worthwhile putting on, selecting these on as soon as you can, because they take a while to start up, again depending on your realism settings. So that's that for this panel for now. down to the fly pad. So again, this should now work once you've got your pilot ID in. And there we go, it's uploaded from SimBrief. It's not the last time we upload. We also do that on the MCDU shortly, but that's as far as we go for the fly pad. So we can look at the fuel situation now. This overview of the 320neo doesn't change. Your operational flight plan is all in here, but the key takeaway from it is the block fuel figure, which is 4962, which is down here, which is as I showed you on the SimBrief part earlier. And then we use that in here. So we basically configure the correct amount of fuel for the trip. So 4962. Down here is your refuel time realism. Press that play button and it will do the business. So I've got mine set to instant today, so that's done. Then we're finished on the fuel side of things. Then we're into ground vehicles, and you can play around with this as you like. It doesn't always work particularly brilliantly. We will most certainly use the tug and pushback options a little bit later on. But I'm going to leave this for now. I don't want to complicate matters and invite things to go wrong, so I will just leave that as it is. But that can add a little bit of realism if you like. Okay, right. So this is when we would look at VATSIM if you were looking to use the virtual air traffic side of things and getting start clearances and IFR clearances and all that sort of thing. But that's really for another day, really. I think it will complicate matters if we go into that too much now. So the next step here is going to the MCDU. And getting this programmed to getting the information uploaded, the flight plan information. Okay, so this is the screen you'll be met with, which is what you'll see if you hit the MCDU menu button. So you need to go into ATSU, AOC menu, and then init press, and this is the initial upload stage. So the information has started to come in, which is reflected there. Go back to AOC menu, weight and balance, and this is where you initiate the loading of passengers if you want to have this level of realism. And so you'll see this number starting to increase as passengers start to board. So that's the initial MCDU setup, and then we go into what's known as the DIFSRIP acronym. I will put some text on the screen to spell that out, but it's DIFSRIP, DIFSRIP. So let's go through that letter by letter. So the D stands for data, which is not something we check in Flight Sim 2020, but my understanding is that this in the real world will be a check of up-to-date navigational data. So we go straight to the I step, which is init A. So you press the init button here, press init request. And again, we have data loaded, and that is it for that initial I step. Then we go into F for flight plan, and this is where I change the view slightly. I come up here, and we need to go into plan, and I will put that into 20 will be fine for now. And this is where we need to look at our SIDs and stars. Certainly our SIDs, arguably you can do your star and your type of approach en route, but we certainly will do the SID, your standard instrument departure. So how do we explain this? If you're not au fait with how aircraft get from A to B within controlled airspace. Essentially, civilian traffic will fly from A to B using a system of airways. So you can think of airways in the same way as you might think of the UK's motorway structure. But in the same way as driving a car down a motorway, you need to work out your route to that motorway. So we do the same here, and you need to work out your route from the airport to that airway structure, and we do that by using a standard instrument departure. So similarly with the standard approach routing, that is your route from the motorway or the airway into your airfield, or more specifically to the start of your nominated instrument approach. But we'll come on to that in a moment. So as far as the departure is concerned, if we go back down to the MCDU and select your departure airfield, which is of course Gatwick, hit departure, select the runway that is in use, which is 26 left today, and then we choose the departure. Now this you can work this out in a number of ways, but if you're on VATSIM, then air traffic will tell you what your instrument departure is going to be, which is why we would have got our instrument flight rules, our IFR departure details prior to this point. But if you're not using VATSIM or air traffic, then you can use what SimBrief gives you, or indeed the Flight Sim's own route planning tool. So looking back at our SimBrief, which I always keep open on a separate screen. Obviously you can't see it here, but in fact I'll drag it across. So here, this is our SID. Okay, Lambourne 6 Mike, which through no coincidence takes us to Lambourne. Similarly, at the other end, we are flying the IMPIP 1 Echo arrival, which through no coincidence starts at IMPIP. Okay, so this is what we need to input. So I need to find, if you scroll up, so I'm using the up and down arrows. The best way to try and imagine this is in the same way as you might sweep up your finger up an iPad, or down. That's the same as pressing the up button here. It's as if you're sweeping your finger up an iPad. So Lambourne 6 Mike, I think I said, didn't I? And then insert. Now, before we insert, let's have a quick look at the navigation display up here. And you will see that whilst we're performing this edit, the intended route comes up as a dotted yellow line. And then when we insert, that becomes a solid green line as our confirmed routing. Now, in this plan mode here, we can now cycle through the navigation points and look at how our route's doing. Sometimes you get these sort of anomalous areas here, but that should be fine. And you can check that there's no anomalies along the route. Okay, and it stops at IMPIP at the moment. So we can come down here and I said we can do it en route, but we may as well do it here, is load our stars. So we hit the button next to Echo Golf Papa Hotel, next to Edinburgh. Arrival, and it's the ILS for runway 24 that we're going to be using. And we are going to be flying the IMPIP 1 Echo arrival there. Okay, and again you can see the dotted line has come up here just north of IMPIP. So let's insert, and then it turns green as our solid line. Right, so if we go back into flight plan and check that route now once more, this is all looking good so far. There's IMPIP, and so this is now the star that we're looking at, and that's our approach onto the ILS into 24 Edinburgh. Now, as we approach this, I will probably not fly the full star. I will probably use our own vectoring, and I'll make that clear what that is when we get closer, because there's no need to do this full. As in going through the centre line and back around. There's ways in which we can modify that. But let's not worry about that now. That looks pretty good to me. Okay, so that is the flight plan stage done. That is the F of DIFSRIP done. So once that is complete, we are then into the R, which is radio navigation, and we are ensuring that the ILS frequency and the identifier is here, which it is. S stands for second flight plan, which is not something we use in Flight Sim 2020. Sorry, that should have come after flight plan actually. DIFS and then R. So, but there we go. Then you're into init B. Okay. Let's get a closer look. So init B. Top right of the screen here indicates whether there is more than one page available to these page options, which in the init case there is. So when we did init A earlier, this is what was populated, but for init B, so pressing this, you have to press the right arrow, and then you get into this page here, which is fuel prediction. So we need to put in the zero fuel weight and the zero fuel weight center of gravity figures here, which I'm not sure if this is correct, but I tend to ensure that boarding has completed before pressing this button here, which is an auto readout of what this figure will be. So if you press this figure, the button here once, it will give you the figure. Press it again, and it will insert it. Now with block fuel, you need to type that in yourself, and that's the number we had earlier, which was 4962. So I'm going to put in 4.9. Okay, so you need to round it up to the nearest 100 kilos effectively. So 4.9 would be how you put in 4,900 kilograms. So 4.9 goes into block, and then you will see estimated fuel or fuel predictions come up here in a second. Okay. Again, I don't take a huge amount of notice of this. It's there. It looks good, and then I move on to the final stage, which is the performance page. And here you have to type in the flap configuration, which is 1/up 0.0. Insert there. Flex temperature, you can insert something in there if you wish, but it's not crucial. But this piece is here in order for the MCDU to be able to automatically calculate the V1, VR and V2 speeds. And the way we insert those is by pressing the button next to the box. So it comes down here, and then press it again and it inserts it. Same for that. We're pretty light today, so the speeds are relatively low, and same again there. And that is DIFSRIP complete. Okay, so I then go into my second stage or third stage of my checklist effectively, and I do in fact, what I do first is I do a check of the flypad, just to make sure that all the vehicles, if I've used them, are back to their starting positions. As I say, I generally don't use them much nowadays, but that's all looking good to me. And then I do what I call is a sweep around the cockpit, and I literally go left to right, checking and adjusting the buttons, etc. that we've got. So starting from left to right, simply increasing brightness on the primary flight display and the navigational display. Loudspeaker is an operative. So that's all good. The navigation display ordinarily should be set to ARC, and 10 or 20 miles is fine. I would use the constraint button, especially when flying a standard instrument departure that has height restrictions or height guidance. I would make sure that Flight Director is on. I would make sure that the QNH is correct, and you can either do that from looking at ATIS, or if you press B in Flight Simulator. In fact, I've inadvertently just gone to Mercury, back to hectopascals. Press B, and there we go. We've got the correct QNH set in. Don't need to play around with the autopilot at the moment. Ordinarily, once you've got your IFR clearance from air traffic, you would insert the initial level in there. If I remember, the Lamborn 6 Mike departure, I haven't got my chart up, I think is initially 4,000 feet. I might be wrong, but I'm going to put 4,000 feet in there anyway. as I'm not using air traffic today, it's really up to me. Moving along, we don't need to adjust anything here. You can select the co-pilot's first officer's display if you so wish, and you can adjust brightness down there, which I'm normally tempted to do because on more than one occasion I've had one of these displays fail, which is interesting. Okay, not too worried about landing gear settings. Obviously make sure you've got 3 greens. There'd be a problem if you didn't at this point. You can reduce the brightness of the standby artificial horizon there, increase the brightness of the 2 ECAM screens here by using the settings down here, and while I'm down here I set that to APU to see what the APU is doing. Make sure all these switches here are in the 12 o'clock position. We don't need to do anything with the MCDU because we've done that. We don't need to mess around with the radios at the moment, so if you use VATSIM there are ways in which that is done automatically. I will adjust my lighting here. It's just probably don't really need to do it during the day, but it's something I tend to do. Certainly in the stable version you can get weather radar. I believe it's saying inoperable here. That is my sweep around the cockpit. And so most settings there will now be correct. Okay, so I now go back to the top panel. And now that the APU is available, which it has been for some time, I can disconnect external power. I now need to select APU bleed, which is, I believe that's what feeds hydraulic power to the engines from the APU to enable engine start. That might not be technically correct, but it's something like that. But you certainly need APU bleed on. Fuel pumps on. Cabin oxygen comes in handy. I switch it on now. Fire testing. Engine fire test, obviously. Do all 3 if you so wish. And then we're ready to go, really. Again, if you were using air traffic, now would be the time to get push and start clearance from VATSIM, or certainly pushback clearance from the Flight Sim automated air traffic. But we're not doing any of that today. We are just in charge of our own destiny here. So I'm just going to call up the tug, and we'll get pushing back and starting. Right, so I will use the fly pad for this. So I'm going to hit the call tug, and you'll see him moving there. I'm going to disconnect my park brake now. While that's happening, I'm going to have a quick look outside to make sure I know where I'm going. So we're using 26 left, so I'm going over here, and I need to reverse around the corner here. So let's go. Right, and as we're moving back, I'm now going to start, and I'm going to switch that around to engine start, and I'm going to get number 2 engine starting. And I need to come round to the left. Now in the real world you will start engine 2 first, followed by 1. It is possible to do both at the same time in the sim, but try and keep it real where possible. When this figure here, M1 gets up to 19% or thereabouts, that's when I generally start the second engine. Now, interestingly there, sometimes it will automatically straighten up. It didn't there, but so I've had to straighten up myself. And we'll stop the pushback there. And we will dispense with the tug by pressing that. Now, the Neo can taxi on idle power, so I put the parking brake on while we're sorting ourselves out. Okay, so a veil has come up here now. In fact, it's just disappeared, which means I will now start the second engine. Tug's gone. So while engine 2 is starting up, I'm going to select flap 1, and I'm also going to select taxi light, which indicates to personnel, vehicles, etc., other aircraft on the ground that you're ready for taxi. Okay, so I'm just waiting for this figure to get up to 19.6 or whatever it is, and it says avail, and then we can pretty much get going. So as far as air traffic is concerned, this is the end of the push and start procedure. The sequence would have been, we would have got our IFR clearance, then followed by push and start, and then a taxi request, which is what we would put in any minute now. So you can see avail has come up. So I'm going to change that back to normal. I'm going to go back to my top panel, and I'm going to deselect APU bleed. I'm going to turn the APU master off. Taxi light is on, and we already know that flaps are selected to 1. And so this is where we would call for taxi. So we can imagine ourselves doing that. We're given taxi clearance to taxi to the hold for 26 left via whatever selection of taxiways the controller desires. Or, of course, in using the normal sim, you might get a blue line that will take you there. Okay, so had a bit of an interruption yesterday, so there's been a 24-hour break since we pushed and started to this point. So hopefully there isn't a continuity issue. I think we are set up as we were before, albeit it's a little bit earlier, but the route is in there and we are just post startup. So I've just deselected APU bleed, etc., and just completed those checks. Right, so let's get moving. So parking brake off. So as I may have mentioned yesterday, I have my joystick set up with 4 power settings: 10%, 40%, 90% idle, because my slider on my joystick was giving me issues with the auto throttle. I also remember yesterday, I think I pointed out the wrong holding point, so we're heading for the right one now for 26 left, and I'll stop here in a minute, and we'll just conduct some pre-takeoffs. Now, in actual fact, I probably should have stopped at the Mike 3 Cat 2-3 holding point. So, but while we're here, I'll explain why you have different holding points. Essentially, why instrument landing procedures are in force, i.e. Cat 2, Cat 3 type landings. The aircraft should be held at the Cat 2-3 holding point, which I am not. And that's just to reduce the possibility of interference with the localizer beams. If we were operating purely VFR, then holding at Mike 1 would be fine. So I've overshot a little bit there. I would be in trouble. Right, so let's just have a look at a few pre-takeoffs. So I've not got a normal SSR code in because I'm not using air traffic, but I would normally have a 4-digit code of some description in there, and I'm going to turn TCAS on. TCAS traffic collision avoidance system works on detecting the secondary radar codes of other traffic. Okay, I'm going to check that my pressure is correct just by pressing B. I've got 1011 in there, which is right. Lights for takeoff. And I'm going to check flap and spoiler. I'm going to arm spoiler in case of an aborted landing, not that I'm expecting that. Sorry, aborted takeoff. Right, okay, so I would have asked air traffic for clearance to depart, and they would have given me a takeoff clearance. So let's get going. So the one thing I have noticed in this development version when using the Lamborn 6 mic and presumably other SIDs as well, is the autopilot is giving me height control, which I have not seen previously. I've normally enter the height increments that you'll have on a standard instrument departure manually into the autopilot. But so today I'm going to put I've just put 6,000 in the autopilot there, and have clicked the up button, which is managed. A quick explanation here of the difference between the up arrow and the down arrow when you're selecting autopilot features. Basically, if you're hitting the up arrow, you're into a managed mode, which is them following what's in the MCDU, both from a speed perspective and a routing perspective, and as it seems also now, although maybe I've just missed it before, is the height perspective or the height constraints that you see here on the MCDU for this particular departure. If you want to override that whilst still remaining in the autopilot but entering your own speeds or headings, vectors or altitude, then you need to hit the down arrow. So I will, once I've got a certain way around the SID, is I will select a higher altitude, simulating air traffic giving me a cruising level, and I'll press the down arrow so that it overrides the flight planned route. Okay, so let's just see if that happens. So I'm expecting the aircraft to stop acceleration at 220 knots and to fly around this corner, and we'll see what the altitude increments do. So there might be an element of surprise here. So, okay. Okay, brakes are off. So again, some real-world aspects to this. I can't get 40% on my throttle, but apparently you go to 40% first before engaging full throttle. Okay, and there's the bug. Speed's low today because we're light. So rotate, looking for 10 degrees initially. Gear. And then I reduce the throttle to the climb setting, which brings in the auto throttle, and then I engage autopilot 1. And then you can put your joystick or control column or whatever you've got to one side for a while. So you need to look at this here. So we're accelerating quite quickly because I'm bringing the flap in. You may not normally, if you're heavy, be able to bring in flap that quickly. So if we concentrate on what's going on in the aircraft rather than looking out for the minute, then we can see that the speed restriction has been applied of 220 knots. As we hit this waypoint here, let's just go to flight pan down here. And indeed it is stopping at 4,000 feet, which is the initial height restriction. I'm just going to very quickly show you the SID here rather than on the navigation display. So we've come out of Gatwick here, we're flying around the corner. This bit here means is giving us the indication that it's a height restriction of 4,000 feet until we get to Delta 29, which is a Detling VOR radial. We can talk about that in a second. We can climb to no greater than 5,000 feet by Acorn, and then round the corner, once we get to Acorn, we can climb to no greater than 6,000 feet, and we must maintain that to Lambourne unless otherwise cleared by air traffic. So we're around the corner here. We are still at 220 knots. So I mentioned the Detling radial. So Detling is a VOR, which is over here. You can type that frequency into the VOR box if you choose, and you can see the Detling VOR come up on the display. We can do that in a minute. But so these points here, Detling 31, Detling 29, are distances from the Detling VOR. Okay, you can just see them in here. I'm just going to try and zoom in a little bit more. So this is working as planned at the moment. Just going to change that second display to fuel and see what the fuel flow is looking like. So yeah, behaving as planned at the moment, as you would expect. And what we'll see when we pass Delta 3-1 is an acceleration to 250 knots. So what I'm using here actually for my charts is ChartFox. So I do subscribe to Navigraph, mainly for the flight planning side, and you can get charts through them. But ChartFox is pretty good as well. It doesn't have everything, but it has the vast majority of charts that you want. You can hear now the acceleration there, and the bug has moved up to 250, and the aircraft will very quickly accelerate up to 250 knots, which don't forget is the maximum indicated airspeed below flight level 100 or 10,000 feet in the UK. And now at Delta 29, Detling 29, I'm expecting a climb to 5,000, and indeed the throttle autopilot, the auto throttle's gone to throttle climb. See the engine M1 increasing, and we're going to add an additional 1,000 feet. I am not touching anything. This is doing it all on its own. So one thing we have to remember in a minute is when we're cleared to a flight level is to change the QNH to the standard altimeter setting, which is 1013. This means this piece here is means altitude constraint, so it's indicating that the autopilot is leveling at a constraint altitude. So back to the chart over here, there's an interesting scenario here potentially, and that is 6,000 feet is a flight level on the other charts, and I believe it is today. I'm sure the transition altitude will be on here somewhere. Transition altitude is the altitude at which you transition to flight levels and would enter 1013. But interestingly, if you go from 5,000 feet to flight level 60, depending on the difference in pressure, that can actually equate to a very small difference in vertical space difference in climb, or a small climb is what I'm trying to say. So I think I worked it out yesterday. 30 feet equates to, or 1 millibar equates to 30 feet. So if you had a low pressure day where the QNH was around 33 millibars less than the standard, so around about 980, then if you're converting from a QNH of 980 to 1013, the difference in altitude would be minimal. And as you change the barometric pressure on here from 980 to 1013, your altimeter would suddenly go from reading 5,000 to pretty much 6,000. I won't demonstrate that right now because I don't want to mess things up, but that's how we the whole subject of pressure settings can be an interesting one. Okay, so we're just passing Acorn, so I'm expecting another climb now as we approach this corner here on the Detling radial. Again, don't worry too much about how this is rendering in the navigation display. That will straighten out, and I wonder if that's maybe just something that's an aspect of the development version which will be straightened out for the stable version once it's put out. So we're not getting the climb, and the reason for that is because I've misread the chart, as the eagle-eyed will see. So here, Lambourne 15, Delta 15 is the point at which we'll actually climb. This is a land-borne radial here, so it is possible to fly this. I mean, this is being flown RNAV or on GPS, but this could be flown by using VOR. You're outbound on the Detling radial, and now we're on the land-borne radial. So you'd set up VOR 1 and 2 potentially. I've not tried that recently, but that is how you do it. Right, okay, so I think we've demonstrated how this works. What we'll do now is we'll imagine that air traffic have given us a cruising altitude of 360, which is probably a little bit unlikely straight off the bat, but let's go for it. Okay, and so the other thing I'm going to demonstrate just while we settle into the climb is a direct routing. So air traffic will often give you a more direct routing if it's available. So we're going to route direct to Leicester. So once you start playing with VATSIM, then you get a direct routing instruction. You press your direct button, find the point that they have given you, which should be something on your flight plan. If it's not, you can enter it up here, but that's again, that's something for another day potentially. So we'll press Leicester, press this button down here, and then it will adjust your flight plan accordingly. And you can see in here that Leicester is our next point. The green line adjusts and Leicester comes up in here as your next point, giving its bearing from you and the distance. Right, so let's just make sure everything is in order. I need to change that to standard up there, so I've just changed the pressure settings to standard, which is then reflected here. But the one thing I do once I have a moment is, again, I just sweep around the cockpit and make sure that everything is set as I would want. So that's okay. Arc plan, we've got the autopilot all set up correctly. I'm going to leave the first officer's navigation display as it is. Probably going to wind up this brightness because we're above cloud now and it's a little bit sunnier than it was on the ground. I've got that set to fuel so I can see the fuel flow, which at the moment is of course pretty high because we're in the climb. Don't need to do anything on the flight planning front because that's all dealt with. And let's have a look at the top panel just to make sure there's nothing I need to change here. Well, we can turn seatbelts off and we can turn the lights off. Oops. Okay, I think we're all good. Right, so let's have a look at the look at the flight plan. Okay, and let's start explaining a few things on here. So one of the key figures on here, we'll certainly need to, is distance to go. So we've got 314 miles, nautical miles, to our destination, and we are expecting to be there at 0650 Zulu, same as 0650 UTC, so 10 to 8. So yes, it is early. What's a nautical mile, if you're wondering? Knots and nautical miles are inextricably linked, as are miles and miles per hour when you're driving a car. So a nautical mile, sorry, a knot is 1 nautical mile per minute, and a nautical mile is based on 1 minute of, I've got to get this right now, longitude. If you're into your longitudes and your latitudes. I hope I've got that the right way around. It's either a minute of longitude or a minute of latitude. I think it's longitude. But anyway, it's based on that. Okay, so this figure here, distance to go, is significant, well, for obvious reasons, but also in calculating our descent point. So I'm going to talk about that quickly now. So it won't be long, we'll be cruising at 360. There is a rule of threes here, or what's called the rule of three, or 3 in 1. So I'll try and make this as simple as possible. When we are cruising at 36,000 feet, if we are aiming to be at 3,000 feet at approximately 10 miles from our destination to be set up for an ILS, it could be 2,500 feet, it could be 2,000 feet, but let's just say for argument's sake it's 3,000 feet. If you're at 360, you've got 33,000 feet to lose. And the way we work out our the distance required to lose that height is by multiplying the thousands by 3. So 33,000 becomes 33, multiply that by 3 and you've got 99. So you would need to descend 99 miles before your intended position where you want to be at 3,000 feet, and that's your descent point. So let's just imagine we want to be 3,000 feet at 10 miles. So as I say, we need to lose 33,000 feet. That's 99 miles. Then as far as this figure down here is concerned, the distance, you need to add 10 to that so that you're at 3,000 feet with 10 miles to go. So that 99 becomes 109. That figure also needs to be adjusted to take into account deceleration. So typically you add another 10 miles to that, so it's 119. And then you've also got to think of the wind. Okay, so let's just keep that figure on our heads for a minute, the 119, and let's just talk about the wind speed element here. So this is your wind speed here, 241 degrees, 92 knots. That is a strong wind, but the arrow here is indicating that it's coming straight across us. That's what it's doing, it's coming in that direction there. It's not coming straight in our face. If it was, we'd have a much lower ground speed, and we'll look at all these speeds in a minute. So as it's straight across us, it is neither sort of in our favour or not. So I wouldn't plan to adjust that 119, and we'll call it 120 for the sake of rounding up. So at about 120 miles, that's when we would begin our descent. So that's the rough rule of thumb. You could argue that if the calculation there is 3,000 feet for 10 miles, then why do you worry about the 10 miles, 10 mile point in 3,000? You could just say, well, I've got to lose 36,000 feet, and 36,000 feet is 108. So 36 times 3 is 108, and then add your 10 miles for your deceleration, 118, same figure. So if I'm being honest, that's probably what I do. I'd probably just multiply the entire figure, because as you'll find as you descend, as you recalculate, and you're playing around with your speeds, as you'll see we may well need to do, you're constantly recalculating and adjusting rates of descent. We'll talk about rates of descent when we actually come to enter the descent. So we know now how far we've got to go until we've got to initiate that descent. So let's talk about a few other bits on here. So the primary flight display shows us a lot of information, typically how the autopilot is running things. So it's set in throttle climb because we're still in the climb at the moment. I'm not going to lie, I don't know what op climb means. I expect to see out star in here, or out star or out constraint, which is indicating how the autopilot is managing altitude. We're obviously in a navigation mode. This AP1 is Autopilot 1 with Flight Director 1 and 2 being selected on both the left and the right. If you were to deselect Flight Director on the right hand side, that would just remove the 2, and we are in auto throttle. Over to the left here, the pink bug is set in managed mode. So this is this equates to 0.786 Mach. Now in the flight plan it was 0.78, so I'm not sure what it's gone up to 0.786, but I would assume that will settle at 0.78 at some point. Out stars just coming in there now as the autopilot levels at 360. Out cruise now that we're level, and speed wise the autopilot is managing a Mach number, Mach 0.78. Mach 1 is speed of sound, obviously we won't be doing that. Mach 0.78 is now where it's settled as we hoped it would. Your red dotted lines up here would indicate where you would start to overspeed. You're more likely to want to keep a lookout of the indications that come up at the bottom part of this scale, which as you slow down, which could be as you get close to the stall. The scale on the right hand side here is your vertical speed, and we can play with vertical speed the minute we are in the descent. And the reason we might want to adjust vertical speed is to maintain a 3-degree glide descent profile, because the rule of 3 or 3 and 1 that I've just explained to you is all based on a 3-degree descent profile. So into the navigation display, again I'll just go through what's on this screen rather than every setting, because this is the main selection you'll have: ARC or plan, nav, VOR and ILS are obviously selections you can make if you're going to use the instrument landing system, but typically I wouldn't. We can demo that later as we fly the ILS, and you'll see what it does. But in terms of the readout that we've got at the moment, GS, ground speed. As the name implies, that is your actual speed over the ground. True airspeed, as the name implies, that is the actual speed of the aircraft through the air. Now, how does that differ to this figure over here, which is saying 260? Well, 260 is your indicated airspeed. That is the speed of the air over the airframe. Now, so why is that figure different from the true airspeed? Well, it's a complicated subject, I think, but effectively it's because as the aircraft is moving through the air, it is pushing a body of air in front of it. There are friction issues, and basically there are a number of things that effectively slow the air that is passing over the wing, and that is what. And so the speed over the wing, or the speed over the airframe, will be less than the true speed of the aircraft through the air, and that is your indicated airspeed figure. Indicated airspeed is crucial because that is what dictates whether the aircraft flies or not. Effectively, if that speed gets too low, you'll stall. If it's too high, you'll overspeed. And it's also in terms of speeds at which you can deploy flap or gear, it's all dependent on indicated airspeed, not your true airspeed. So ground speed, true airspeed. Your ground speed will be different to your true airspeed because you're traveling through a body of air that is moving, and the wind effect is what will adjust that ground speed. So the most dramatic effect, or when you see the most dramatic differences between true airspeed and ground speed, is when you've got a significant headwind. So if we were flying directly into a wind of 100 knots, our ground speed is going to be about 100 knots less than our true airspeed. Okay, here's Leicester. But today our ground speed is pretty decent because we've got no headwind. But you can see also the effect of the headwind here, and that is this is no mistake on the display here. The aircraft is facing or is heading to the left of its intended track. The track through Leicester is 327 degrees. The track we are flying is nearer 314 because we have to offset for this very significant wind that's coming off our port side, off our left-hand side. Okay, so let's see what comes in after Leicester. According to this, it's going to be Embor. We're already down to 230 miles. We've got only 110 before we're looking at descent. And it's changed to Embor as we would have hoped. Okay, so I think I'll probably speed things along to the descent point. Okay, so we're at 128 miles to go, and we're level at flight level 360. So as we said earlier, 36 times 3 is 108 plus 10 for deceleration, around about 120, and we'll start our descent. So I've zoomed in a little bit to try and concentrate on the key parts of the display. The eagle-eyed amongst you again will notice that the time has changed to 11:29. I've had a real-world interruption which meant I had to delay a little bit, but it shouldn't make much of a difference. The weather seems to be largely the same, although we'll try and keep heads down whilst we're carrying out this procedure. So 123, so I think we'll commence descent there. So initially I'm going to go to flight level 260. I'll explain why in a minute. So I hit the down arrow and the autopilot has gone into an idle descent, indicated by throttle idle here. Now what we need to keep an eye on is this rate of descent. I'm just going to set something now and I'll explain why in a moment. So the rule of 3, or the 3-in-1 descent, is based on a 3-degree glide path. How do we know whether we're on a 3-degree glide path or not? Well, one way of doing it is by looking at this figure here, the ground speed figure, taking the hundreds and the tens, so 4.5 in this case, 4.6, dividing that by 2 to give you 2.3, and then that is the rate of descent in hundreds of feet that you should get. So effectively this figure here, 2.2, should be half of this figure here, 4.6. Simple as that. If it's greater than half, your rate of descent is going to be greater than 3 degrees. If it's less, obviously it would be less than 3 degrees, and so you can test and adjust that throughout your descent. So I've got 2.3 set in there, 2.2 set in there at the moment. I'm going to make that 2.3. You don't need to press down every time, it will reflect in here. So what I'm looking at in terms of the my descent profile is this, which is the star, and that's telling me I need to be at IMPIP at flight level 260, although when I read through this it makes it quite clear that actual descent clearance will be as directed by ATC, so we will discard this, although we will keep an eye on minimum terrain levels, but I'm not going to take note of these levels in here for the minute. I will assume that we're on an air traffic clearance, but what I will look at is the ILS chart. Just try and open that up a little bit. So we should have significant detail on here. Well, there's a lot of it, but suffice to say the procedure says you are to be level at 3,000 feet altitude by DME 12, 12 DME, and descent is going to be around about 9 miles DME from 3,000 feet altitude. So that's what we're aiming for. And the one thing I'm going to check in here is the frequency of the ILS, which is 108.9, and I need to make sure that that is what's in my MCDU. So let's do that now. 108.9. Okay, so that's all good. I'm now going to route direct to tartan. So if you remember, we hit the direct button, then tartan, and then direct. And let's just straighten out that line. And we need to be at flight level 70 or below by tartan. Chances are we'll be below that. Okay, so 29,000 feet, 29 times 3 is 87, 87 plus 10 for deceleration, 97, 93 to go. So we actually need to increase this rate of descent. We're a little bit behind. I'm going to bring that down to 7,000, and I need to, of course, once we're descending to an altitude, we need to change to a QNH. We're still on the standard pressure setting of 1013. So I fear we're a little bit high, so I'm going to put speed brakes out. And drop the speed, obviously. So let's see how that's looking. 26 times 3 is what, 78 plus 10, 88. So we're bringing it back a little bit, 86. You just need to constantly reassess this as we're descending. 25 times 3, 75 plus 10, 85. So it's coming down. Ground speed 430, so divide that by 2, we're in sort of 215, so that would be 3 degrees, but we're 3,000 feet rate per minute descent at the moment to get ahead, because we're a little bit behind the curve. Maybe because we've got a bit of a tailwind now. If we look at this arrow here, that's highly likely to have something to do with it. So I'm just going to stay like this for the minute. Speed's not coming down, which is not a surprise particularly, given this rate of descent. So we'll keep the speed brakes, the spoilers, speed brakes out for the minute. So once we get to tartan, I'm going to manually vector us. We've got 40 miles to run, which is reasonable distance, no concerns at the moment. So let's say 21 times 3 is 63 plus 10, 73, so 75, we're ahead of the curve now. So I'm going to bring that back to the 3 degrees, which would be just under 2. And that reduction in the rate of descent will enable our speed to reduce. So as the nose of the aircraft comes up, we should see a reduction in speed, and indeed that's what we're starting to see. What was below flight level 100 is 250 knots or less. So everything's looking okay at the moment. Just starting to think ahead of brakes. I'm not too worried about braking action today, but standard auto brake is set to medium. Spoilers, speed brakes, ground spoilers would be armed for landing, so that they deploy the minute we touch down. Okay, so A318 is 54 plus 10, 64, 68. So we're now looking better than we were a minute ago, and the speed is coming off. Its way down to just below 250 knots. And I'm I've got descent now there to 7,000 rate of descent. Okay, 33, half of 33 is what, 16.5, so we can drop that. Let's call it 17, let's not get behind again. So 17, 3 17s, 51, plus 10 is 61, so we're at 64, so that's all good. Just so I don't forget, I'm going to put some lights on now. Seatbelts if you want. I don't think we've actually got any passengers on board, but we'll do that. So everything's looking okay. I'm going to select landing system there so that the ILS is ready. But I'll be looking at modifying this a little bit just to demonstrate how you can put a manual vector in. This is where the runway is. In fact, this is where the runway is here, and the track is taking us through the center line. Let me zoom in. The track is currently taking us through the center line, so we're not going to do that. We're going to get to Tartan, and then I'm going to fly like a box and feed in to the ILS on a roughly northwesterly heading. How are we doing then? 15, 45 plus 10, 55, 57. Okay, I'm going to increase it slightly actually. Small adjustments. We've got 250 knots, so I'm going to bring in the speed brake. Just wind that in. Yep, so about 20 miles to go to Tartan, flight level 70 by Tartan. Just looking on the charts, safe altitude is around about 5,000 feet. So 70 today will be fine. But as I said, this would realistically now be your levels, speeds, headings would all be dictated by Edinburgh approach at this point, I would have thought. Again, looking around, there's not a great deal we need to do at the moment. We're just monitoring the rate of descent. 312s are 36 plus 10, 46. So we're ahead of the game. 250 knots. I'll bring that down to an intermediate 210. But I'm not going to try and lose any more speed whilst I'm in the descent. It's worth pointing out at this point that I'm not saying this is the right way to do it. This is just the way I do it. I am in no way qualified on a 320, but this is just what I've gleaned over time. I think as long as you're at 10 miles at 3,000 feet or thereabouts on this particular procedure, and at around, well, probably realistically around about 180 knots, then how you get there is up to you. Whatever works for you. So. Okay, we're at 11,000, so 33 plus 10, 43. Again, we're pretty much on the button there, which is good. So I'm going to continue descent to 5,000 feet. I'm going to change to the QNH, which is 1001. I've just pressed B to make sure that's correct. So Edinburgh QNH 1001 is in there now, 5,000 feet, and that is a safe altitude. Okay, so I'm going to vector now. So I'm going to, we're heading around about 3, 4, 5, where the yellow bug is here. So I'm going to come right. I'm going to aim for about here. So right about 15. So let's see how good that maths is. for my estimation. So due north. Again, this is what air traffic would be doing, especially if they've got a number of aircraft in the pattern that they're having to separate. They will start to vector you. Okay, what's that like? I'm going to give it another 5 to the right. I'm going to bring down the scale there so we can see it a little bit more easily. .38 miles to go. Although that's not going to be entirely accurate now because we've started to vector ourselves. That will still be going off the flight planned route. You see it's picked up the ILS now, 108.9, 20 miles DME, so that's straight line, 20 miles distance to the Edinburgh overhead, which is matches up with that. Edinburgh is sat on the 20-mile range ring there. We certainly wouldn't sort of enable the localizer at this point. That is not the stage at which you do that. So we're past Tartan. I'm going to continue descent now to 3,000 feet. I'm not sure if that is correct in terms of a safe altitude or not, but for the sake of the video, we'll do that. But it's all looking reasonable. The idea is I'm going to get to about this point here, and then I'm going to come left 330 or thereabouts, probably 340. And then look for around about a 30 or 40 degree cut onto the ILS. So if the ILS is 240, it's not, if I look on my chart, it's, what's the course? 241, so near as damn it. Plus 30 degree cut 270, 30, 40 degree cut. Okay. All looking good out the window. So don't forget, I'm aiming to be here, which is 10 miles finals at 3,000 feet. And we are there ahead of time. We've got 1,000 feet to go. As soon as we're level at 1,000 feet, then I'll start, I'll look to bring off the speed. So what have we got? About 15 miles to go before we intercept the centre line. All looking fairly reasonable. So the when we're estimating the rate of descent, it is a case of constantly adjusting it, recalculating as you go down, seeing how you compare to the track to go, distance to go, and making fine adjustments with the rate of descent.
2,500.
So that's the rad alt readout, so 2,500, not our actual altitude.
2,500.
Distance between the aircraft and terrain. So we're just about a level at 3,000 feet. We won't be descending any further. That's the level that we need to be at according to the chart, 10 miles for descent at 9. But what I will do now is start dropping the speed off, and speed will come off very easily now that we're level. So I'll go to an intermediary, I'll go to 225 initially, which is just under the first stage of flap. As you see, the throttle will drop, speed comes off without any problem at all. And I'm keeping an eye here on our vectoring. I'm going to come left a little bit to be expeditious. Let's go left to 355. Don't want to cut it too fine. Let's see what happens if I go down to 10 miles. Yeah, that's okay. Quick look out the window, we're all happy there.
2,500.
Speed 220. 225, sorry. And I'm going to go left onto 340 now. Onto what you would call a base leg. So don't forget, air traffic are probably doing this with about 4 or 5, or Heathrow would be doing it with more than that. Vectoring and controlling by speed and height. I'm going to come around a little bit more, 335. I've got a very strong westerly wind, which is going to be pushing me over to the east. And I'm going to drop speed now. I've got about 5 miles to run to the centre line, so I'm going to get down to 180 knots. And I'm going to put down the first stage of flap. Because I want to be here, 3,000 feet, at 180 knots. I'm not going to be over that point, I'm probably going to be somewhere around here. But 3,000 feet, 180 knots. Okay, and speed is there. I'm actually going to drop gear at this point. And I'm going to... Oh, no, that's speed. I'm going to come left. 1 to 280 as we look to intercept the localizer. And once I've dialed this in, we'll have a quick look at the PFD and explain what's going on there. Okay, so we're coming left onto 280. The diamonds are what indicate the glide path and the centre line. So the glide path, you've got to imagine that yellow is where the aircraft is, the diamond is where the glide path is. So the glide path is currently above us. I'm going to hit a localizer now. And it's unusual really that we would intercept the glide path before centerline, but that's just how it's happened on this occasion. And generally the rule of thumb for me is when the diamond hits the line, I hit the approach button, which then means that we're about to descend. So I am now going to go to a further stage of flap. I'm going to reduce speed. This is probably not textbook, if I'm being honest. But essentially we would hit the localizer, sorry, just go on that bit. Hit localizer, then the approach. Localizer.
2,500.
Okay, I'm going to go next stage of flap. I'm going to bring the speed back. 145 is effectively what you're aiming for ultimately. I'm going to go to 155. We're on glide path and we're on the centre line. 155. Just checking that's fine for full flap, which it is. Okay, spoilers are armed. We've got brakes set to medium. We're all good. We've got 6 miles to go. I'm going to reduce the speed to 145. And then essentially we are preparing to take over manually, which typically I tend to do at about 2.5–3 miles. Whilst we've got a second, we can switch that to VOR. Sorry, ILS. And this is what you would be using if you were flying the ILS manually rather than with the Autopilot. But I don't think that's done very often nowadays, I would imagine. Okay, so you can just about see the runway, but and we've got quite a wind coming just off the one aircraft's 1 o'clock, which is why we're pointing away from the runway. The runway's over here, so this could be interesting. But we're looking good. Gears down, 145 knots. Flap is fully extended. I think if winds are particularly high, there's a possibility you may not go for full flap. I'm not sure whether that applies to large airliners.
$1,000.
So, just coming up to 3 miles. Okay, so I'm going to disengage the autopilot there. And then we're looking at the Pappy's looking for 2 reds, 2 whites. I'm a little bit low, I've got 3 reds, but that's okay.
400.
Clearly got this wind.
300.
And we've now got rain.
200. 100. 50, 40, 30, 20. Retard. 5.
Okay. And we're down, and we'll find that the brakes will kick in. And if you want to roll out a little bit further, then you can deselect the brakes down here and use your manual braking. Okay. Down to a reasonable speed, and then we'll vacate. As soon as you clear of the runway, you give a shout to air traffic to say runway vacated, and they can then give the following aircraft a clearance to land. Okay, that's pretty much done. So that's been quite a long old vid. It's taken us through a number of aspects. I hope that's been useful to you. If you have any questions about anything, I appreciate it. There's a few things I missed. I didn't do the VOR tuning in the end, but if there's anything missed that you want to see, then then let me know. Okay, thanks for watching.